Hello everyone. Today I'm going to discuss about binomial and Poisson distributions. Let us go through this all topics that we can understand them in detail. So first we have a brief introduction about them. That binomial and Poisson distributions are the probability distributions that are commonly used in statistics and probability theory. They both are discrete probability distributions, that number of successes or events that occur, number of trials are or a fixed interval in a time. This was the basic introduction about binomial and Poisson distributions. Let us go through this binomial distribution. Binomial distribution is used when there are only two possible outcomes, often referred to be a success and failure. It is characterized as two parameters: the probability of success in a single trial, denoted as P, and the number of trials, denoted as M. The binomial distribution can be calculated by the probability getting a specific number of success in a trial. So let's learn some basics about Poisson distribution. Poisson distribution is used to the model of a number of events that occur in a fixed interval of time or space. It is characterized as a single parameter, often defined as lambda, which represents the average rate of events occurring in the interval. The Poisson distribution can be used to calculate probability of a specific number of events occurring in a given trial. So let's discuss about common points and difference of binomial and Poisson distributions. And both binomial and Poisson distributions can be used in several applications in various fields like finance, biology, engineering, and understanding these distributions essentially for analyzing and making informed decisions based on probability and statistics. Let us know some interesting differences about them. Binomial distribution, there is a fixed number of trials, whereas in Poisson distribution there could be many number of events that occur during certain time interval. And these were the examples about them. It's like flipping a coin 3 times and how many customers will arrive at store in a given hour. And the similarities about them, both distributions can be used for model the number of occurrences of same event. In both distributions, the events are occurred independent. The events are assumed to be independent. So before going in depth understanding the distributions, let's just understand the probability basics. What is probability? Probability is a branch of mathematics that deals with likelihood of events occurring. It provides a framework for understanding and predicting outcomes in uncertain situations. Relevance to binomial distribution. The binomial distribution is a probability distribution that models the number of successes in a fixed number of independent Bernoulli trials. It is used when there are two possible outcomes and success or failure. The probability of the success remains constant for each trial. It is one of the important point in binomial that probability of success remains constant for each trial. Whereas relevance to Poisson distribution, the Poisson distribution is a probability distribution that models the number of events occurring in a fixed interval of time or space. It is used when the event occur randomly and the average rate of occurrence is known. So average rate of occurrence in Poisson distribution is known. So let us in-depthly discuss the binomial distribution first. The binomial distribution is a discrete probability. This was the basic definitions which we have already discussed. So let's go to the properties of the binomial distribution. Each trial has only two possible outcomes. This was also discussed that there are success and failure. The probability of success remains constant for each trial. The trials are independent, meaning the outcome of one trial does not affect outcome of another. The number of trials is fixed. The binomial trial is distribution of trial is often used for situations as the number of coin flips, the number of defective items in a product batch, or number of sales calls in a given number of items. These were the bottoms one are the examples about them, and let's discuss one of the example in detail. That is example problem on binomial distribution, that is coin toss experiment. So we have given a problem statement that a fair coin is tossed 10 times and the goal is to determine getting 5 hits. So here is the formula for a binomial distribution, and we are going to solve it. Before we are going to solve it, what are the terms of that formula? We need to know that. So where n is the number of trials and k equal to number of successes and p equal to probability of success in a given trial, and nck equal to the number of ways to obtain k successes in n trial. In this given case, n equal to 10 as a number of trials equal to 10 and k equal to 5 means the number of successes. We need 5 heads, exactly 5 heads. So it is case of thing, and p equal to probability in a given trial, that is 0.5, as it is given it is a fair coin. And putting all these values in that formula, we can get this output that 0.246 is the probability. That means 24.6 percentage of thing is there that we can occur, that 5 heads can occur after tossing this thing. So let's go to the in-depth understanding of Poisson distribution. Poisson distribution is a discrete probability distribution that describes number of events occurring in a fixed number of time or space given the average rate of occurrence on the independent sequence. The characteristics of Poisson distribution, the characteristics or properties of Poisson distribution are mentioned below. The mean and variance of a Poisson distribution are equal and both represent as parameter by using lambda. The shape of this distribution is determined by the value of lambda. As lambda increases, the distribution becomes symmetric and bell-shaped. The Poisson distribution is memoryless, meaning the probability of an event occurring in a given trial is not influenced by the past events or the last event. The Poisson distribution is often used in variant fields such as insurance, telecommunication, querying, model of occurrence, and such as this are applications of Poisson distribution. Let's go through an example in Poisson distribution. So it is an example. We are going to calculate the arrival time calculation. Suppose a call center receives an average of 10 customer calls per hour. We can use the Poisson distribution to calculate the probability of specific numbers arriving in a given period. Let's say that receiving 15 calls in an hour of 2-hour period. So here is the formula for Poisson distribution. You can note that out, and we are given the terms according to the problem statement, that is x is random variable, k is number of calls we want to calculate probability for, and lambda is the average calls per hour. And by substituting these values, this is for you guys, it asks for you can calculate that, you can have that. So please note that this is note point that Poisson distribution assumes the event occur independently at a constant average rate over time. It is the note, guys, you all must need to remember that. And let's go to the summary. You can go through all these points. These are important points which I have all discussed about that, and I have noted them down in a slide of page that you all can go through that for further understanding. And the takeaways that I have included in that is binomial distribution is used that with all things. You can also go through this is an important thing, and overall, like when you have to revise that in a 1 minute, so you can revise the definitions, that way I mention it. Thank you guys for watching this video.